In this video, we are going to talk about the intersection between a line and a plane. Okay, so when we talk about a line and a plane, there are mainly three intersections. Okay, the first thing is either the line can be parallel to the plane or the line is not parallel to the plane. Okay, so let's say this is the plane. Okay, so let's say this is the plane. Okay, and let's say this is a line, and let's say this is another line. Okay, see this is another line that passes through the given thing. Okay. Yeah. So here we have two types of interaction. One is line can be parallel to the given plane. Okay, let's say this is the line L1. It can be either parallel to the plane, okay, or it can pass through the plane. Okay, which means it is not parallel to the given plane. Okay, and if the line is parallel to the plane, it can either lie over the plane or under a plane, or it can lie on the plane. Okay, let's say this is L3. Okay, well, in this case, L3 is parallel to pi at the same time it lies on the plane. Okay, so this is what we are going to talk about today. Okay, so in this video, we are going to talk how we can find if a line is parallel to the given plane, and if it is parallel, how can we know whether this line lies on the plane or not. Okay, in the next video, the second part, we are going to talk about if a line is not parallel to the plane, how can we find the intersection point. Okay, so if the line is passing through a plane, it has to pass through a given point. Okay, that's the idea, and we can find the point if we do some calculation. But first of all, let's focus on if a line is parallel to the plane, how can we find that? Okay, so if a line is parallel to the given plane, okay, if a line is parallel to the given plane, the idea is that the normal vector, okay, the normal vector to the given plane will also be normal to the given line. Okay, let's say this is the normal vector n. Okay, let's say this is the normal vector n. If phi is perpendicular to the vector n, if the line is also, let's say this is the line L, if L is also perpendicular to n, we can say L is parallel to phi. Okay, L is parallel to pi. Why is that? Well, we know this angle. Okay, since n is perpendicular to pi, we can say this angle is 90 degrees. Well, this angle will also be 90 degrees if L is perpendicular to n. Well, then these two are parallel to each other. The plane pi and L are parallel to each other. Okay, and and if it lies on the plane, okay, if the line L lies on the plane, the idea is that any point on the line, okay, let's name this line as L2. Okay, let's name this point, a line as L2. Any point on L2, okay, I mean, if we get the vector equation or parametric equation or the Cartesian equation of L2, we can find infinite number of points. Ilaya? We can find infinite number of points on L2. Okay, if a line is parallel to the given plane, okay, let's say L2 is parallel to pi, and if any point on L2 also present in phi, okay, we can say L2 is parallel to the given plane as well as it lies on the plane. Okay, it lies on the plane. Okay, this is all cute and stuff. Okay, obviously there are some theories. Okay, fine. How can we do this actually? Well, think about this. If a line is parallel to the given plane, we can talk about the direction vector of the line. Let's say L is given as a plus lambda b. Okay, a plus lambda b. We know a is the position vector of a point on the line. Okay, I forgot r here, so let me write down r also. R equals to, okay. So a is the position vector of a point on the plane, and b is the direction vector. So if line L is parallel to the plane pi, that means the direction vector b, okay, the direction vector b is also parallel to the plane pi, okay, which means n is also perpendicular to the given direction vector b. Okay, so how do we find this? If b dot n is equals to 0, you can say B is perpendicular to N, which implies L is perpendicular to N, which implies L is parallel to phi. Okay, this is the first thing. Okay, and if the line, we know the A is the point, the position vector of a point on the line, Ilya. So if you do this, okay, I mean, we can give the Cartesian equation of phi as ax plus by plus c z is equals to d, Ilya, which is actually, what does this mean? Well, r dot n is equals to a dot n. Okay, so this is the actual equation. Okay, so the thing is, if let's say L2 is given as r equals to c plus mu d. Okay, first of all, d has to be perpendicular, which means d dot n is equals to 0. Why d has to be perpendicular to the normal vector n? That is one condition. The next condition is the c vector or the point on the L2, the position vector of point on the L2, c dot n should also be equals to d. Okay, d. Which d? This guy d. Okay, so this is the idea. So let me summarize this for you. Okay, let's say there is a line L which is given as r equals to a plus lambda b. Okay, a plus lambda b. If, okay, let's say phi is given as ax plus by plus cz is equals to d. Okay, and phi is perpendicular to n, which means n is the normal vector. Okay, so L, okay, if b dot n is equals to 0, that implies L is parallel to the given plane phi. This is the first condition. Okay, at the same time, if a dot n is equals to d, okay, first of all, this condition should be met. Okay, then only we can go to this condition. Okay, if a dot n is equals to d, that implies L lies on phi. Okay, it doesn't have to be a always. Okay, it can be any point on the given line. Okay, it can be any point on the given line. This is the idea. Okay, or how you can understand this is, let's say a is given as a1, a2, a3, and b is given as b1, b2, and b3. Okay, this you can find out this such that a b1 plus b b2 plus c b3 is equal to 0. Similarly, this guy you can write it down as a a1 plus b a2 plus c a3 is equal to d. Why? Well, we know if the Cartesian equation of the plane is given as ax plus by plus cz is equals to d, that means n is equals to a, b, and c. Okay, you can use either method. Okay, however, this is the basic idea. Okay, if b dot n is equals to 0, line is parallel to the given plane. If a dot n is equals to d, that means the line lies on the plane. Okay, let's do some practice question. In this question, they are telling us that L is given by this vector equation and pi is given by this Cartesian equation. What we have to find is if line L is parallel to the plane or not. If the line L is parallel to the plane, okay, we have to see whether it lies on the plane. Okay, let's do that. So let's define B as 332. Okay, so that implies, I mean, why we do this? Well, to find out whether the line is parallel to the given plane. So from this, we can say n is equals to 4, minus 6, and 3. Okay, so we have to check whether b dot n is equals to 0. That's what we have to check. So b dot n can be given as 4 into 3, so it will be 12, minus 6 into 3, it will be minus 18, plus 3 into 2. So it will be equals to plus 6. So that is equals to 0. This implies L is exactly parallel to the given plane phi. Now we have to check whether this line lies on the plane. So let's say A is equals to 5, 2, minus 3. Okay. It doesn't have to be 5, 2, minus 3. Okay. It can be also 8, 5, minus 1. How did I find that? Well, I substituted the value 1 for lambda. Okay. I'll do for these two ones. Okay. I'll do for these two ones to show that it will be the same answer. Okay. It will be the same answer. First, let's do for this guy. Okay. So let's say this is A1 and let's say this is A2. Okay. So we have to check if A1 dot n is equals to D. That's what we have to check, whether if it is equals to 5. So it will be 5 into 4, 20, 2 into minus 6, minus 12, minus 3 into 3, it will be minus 9. So that is equals to minus 1, which is not equals to 5. This implies L does not lie on 5. Okay, does not lie on 5. Now try with these three numbers. Okay, try with these three numbers. So A2 dot n is equal to 8 into 4, 32, 5 into minus 6, minus 30, plus 3 into minus 1, minus 3. Whatever the value is, you get minus 1. So this is also not equal to 5, which implies L does not lie, L does not lie on 5. Okay, so the conclusion is L is parallel to pi, but it is not lying on the plane phi. Okay, that's it. That's all you have to know here. Let's do another question. Yeah, it's the same question. They have given us the line L and the Cartesian equation of phi. We just have to find if line L is parallel to pi. If it is parallel to the pi, we have to check whether it lies on pi. Okay, do it by yourself. Okay, pause it and do it by yourself. Then you can check the answer. Okay, so the first step. Okay, let's say B is equals to 4, 5. Okay, so B dot n, we have to find that. So B dot n will be 4 into minus 5 minus 20, minus 2 into 5 minus 10, plus 5 into 6, it is equals to 30. So that is equals to 3. So this implies L is actually parallel to the plane phi. Okay, now let's say A is equals to 1, 2, and 3. So A dot n will be equals to minus 5 into 1 minus 5, minus 2 into 2 minus 4, and 3 into 5, it will be 15, which is equals to 6. So it is equals to 6, which implies L lies on 5. Okay. So you may think, why am I replacing the x value with 4, y value with 5, and z value with 6? Actually, the perpendicular vector or the normal vector is given as minus 5, minus 2, and 5. How do we find that? Well, in the Cartesian equation, the coefficient of coordinates will be the coordinates of the normal vector. Okay. And if you do the scalar product here, okay, let's say b dot n, that looks like this: 4, 5, 6 dot minus 5, minus 2, and 5. And this is equal to minus 20, minus 10, plus 30. If you look at this, it is the same as this guy. So that's why I'm directly replacing the values. I'll also clarify another doubt. I already said that A doesn't always have to be 1, 2, 3. It can be any other point on the given line. Yeah. So let's say lambda is equals to 2. Well, then A will be equals to, okay, 1 plus 8, it will be 9. 2 plus 10, it will be 12. 3 plus 12, it will be 15. Okay. So now let's take this. A dot n is equals to 9 into minus 5 minus 45. 12 into minus 2 minus 24, 15 into 5 plus 75. So that will be equals to minus 69 plus 75. That will give you 6. So this is equals to 6, which implies L lies on 5. Okay, so I will recap these things. Okay, again. So you have three possibilities. Okay, with a line and a plane, you have three possibilities. The first possibility is that line can be parallel to pi, and if it is parallel to pi, you can check whether it lies on the plane pi. Okay, L lies on pi. Okay, if L is not parallel to pi, then only we have to find the intersection point. with the plane and the phi. So it looks like this. This is the plane phi, okay, and the line will pass through the plane, okay. The line will pass through the plane. Let's say this is L and this is phi. There will be an intersection point. That's what we will have to find. Okay, we'll look at that in the next video. Okay, keep practicing. Okay, so we just have to say if D dot n is equals to 0, that implies L is parallel to phi. A dot n is equals to D. That means L lies on phi.
Thanks for watching the tutorial video in our vector series. If you found this explanation of line and plane interactions focusing on parallelism helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist for master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.